All right, let's start off with binary search. It's going to be our searching algorithm. What we're going to do is we're basically going to cut everything in half as we go through it. So if you look at the example, we're going to look for the number 13. We're going to start by grabbing the middle. In this case, kind of round down. We're going to grab 11. Is our number bigger than or equal to 11? Yes, it clearly is. It's 13. So what we're going to do is we're going to start searching now between 13 and 52. So we're going to move down. We're going to have the middle again. That's going to be 22. Is our number going to be bigger than 22? No. So now we're going to go to the left side of it. Let's look through 13 and 20. And we're going to start in the middle again. It's going to be 19. Is our number bigger? No. We're going to go to the left side of it. Bam, we got 13. Let's dive into the code. First things, before we get into the code, I want to clarify something. I shouldn't have used an equal sign there. It should have just been, is it bigger than? Because every time we go into this, what we want to check is, we're looking for 13. Is our middle value 13? With that clarified, now let's jump into the code. All right, so to start, let's kind of knock out some pseudocode here and see if we can follow along. So the first thing we're going to do is we're going to pick a middle. Grab the middle end of the list. We want to check, is the middle our value? If it is, let's just end. If not, is the middle bigger? If it is, search to the right. If it's smaller, search to the left. Otherwise, repeat until we are done. All right, let's start writing some code. Let's create a function called binary search. It's going to take in a R array, and what are we going to call this? Num searching for. Sorry, I like to be very explicit with my names. All right, so the first thing we need to do is we need to know where we're starting and where we're ending. This is how we're going to control what part of the array we are actually looking through. So in this case, we're going to set it to start with to the length for array -1, because we have to compensate for the fact that we have the length is not going to start at 0, but the indexing is going to start at 0. So this allows us to compensate for the fact that the array indexes at 0. Okay. So we go up here and we've got our first step, repeat until done. Kind of screams a while loop to me. So let's say all the start is less than or equal to the end. That'll be our flow control. Eventually, as we -1 or add 1, we're going to get to where this actually kicks out of here. If we get kicked out of here and we don't have anything to return, if we get kicked out, we're just going to return a -1. That means we didn't find our array, we didn't find a match, and let's just return -1 to show that there's nothing in here. So we've got this part done. Go to our pick a middle. So our middle equal math.floor. Then our math.floor, let's take our start plus our end. Just divide by 2. That is going to give us our middle number, rounded down. From there, let's just check if our middle equals the number we're searching for. That means we found our array middle. That means we found what we're looking for. So if we found what we're looking for, let's just return middle, and I'll return the index of our number. Else, if our array in the middle. So our middle value is going to be less than the number we're searching for. So in this case, and I'm just going to copy this over here real quick so we can kind of explain this part. Let's say this is our array. First number we're going to pick in the middle is going to be 11. Just say we're searching for 13. So else if the number in our middle is less than 13, which in this case it is, then we're going to start searching through this side. So how are we going to do that? How are we going to say we're going to search to the right, just like up here? Well, one way we can do that is we can change our start position. Now let's make our start equal to our middle plus 1. And what that's going to do is we're going to make the start position right here. Our end's still going to be the length of our list minus 1, so we're going to search over here. Otherwise, if our number is smaller, need to case there, let's change our end to our middle minus 1. So in this case, if our number is smaller, let's say we're searching for 8, is 8 smaller than 11? Yes. Our start will still be here, but all we're going to do is we're going to move our end to the middle minus 1 to this index. Then after that, we're just going to keep repeating until we get it done. All right, let's run our code. In order to run our code, let's call our function first. So let's console.log binary search, pass it our array. Let's search for 13. Right, so return that we're at the 7th index, which is 13. And I found it. Let's break down a little bit more about how it did that, what the flow was. So in here, let's just console.log out our middle. Let's see what was happening. And I made a mistake there. Let's console log. Let's actually look at which number is at that index, rather than just the index itself. Let's run that again. Okay. So our first time was 11. Is 11 bigger than or smaller than 13? Well, or it means 13 bigger than or smaller than 11. It's bigger. So now we looked over here between these numbers. And we grabbed 22 as our middle. And now is 13 bigger than or smaller than 13? Or is 20, yeah, 22 is bigger. So we went to the left. Now we're going to look at 13, 19, and 20. 19 is going to be our middle. It's right here. We're going to say again, 13 is smaller. So let's go to the left. And when we got to the left, we grabbed 13. And up here in our case, 13 is equal to the number we're searching for. So we return its index. Its index is 7. I hope this helped. Thanks for watching.